Okay, so this lesson we're going to look at geometric decay. So remember, geometric is always when we're multiplying by a common ratio, and which we now are calling, we're going to see it's called a big capital R in our formulas. And so because we're going to do decay, that's when it's reducing. So decay means reducing, and we're going, oops, sorry, I think I spelled that wrong. So we're going to be looking at a financial situation of geometric decay. And what it's actually called is reducing balance depreciation. So like what we were talking about, it's like the opposite to compound interest. So you're going to, it's the opposite to compound interest. So what has happened is the item's going to reduce by a percentage. So say we'll say our item is $1,000 and we reduce it by 10%. So that means it'll drop by 100. So say in the year one, after 1 year, it's now $900. So then you get 10% of that $900. So in the second year, it drops by $90. So can you see that's the difference? So it's the same percentage, but when it's reducing, so the amount is actually, it's because you're compounding the reduction, it goes down small. Sorry, you're reducing it. So the difference is when you have flat rate or unit cost, it's always the same amount. So we can see it's going to be a different amount every time. So here's our reducing balance formulas. So remember in the first column, we've got our recurrence relation. So if it's highlighted, so this probably should be highlighted too, but if it's highlighted, you need to work that situation out for your scenario. So you remember, you always state the original value and then you put the n+1 rule. So you can see in this common ratio here, you can see here's the formula for it, and you can see you've got that little rate again, the rate per annum. So remember that is the percentage rate. They might sometimes write PA when they give it in the question, so that just means per annum, and remember that's the yearly rate. And then if we're reducing by, say, the same, if it's yearly, remember PPY would just be 1, but if it's something like quarterly, remember we divide by 4 and so on. So it's still the same. Now in the middle here, we have our nth term formula. So you can see we use that R, and then once again it's the power of n times the original. But this time we're going to see this R value, and you might want to write there, the common ratio in this scenario, or that capital R, is going to be equals a number less than 1. Less than 1, but bigger than 0. So just so you know, just pop in a little example in so you get it. So example, it could be 0.9, yeah? It's less than 1 but bigger than 0. Okay, so we're going to go through some examples of our reducing balance depreciation. So a car is purchased for $18,500. So once that they're giving you the VO there, what the original price is. And the following recurrence relation can be used to model the car's value as it depreciates by 10% each year. So when they say it's going to depreciate 10% off its value, so see how it says of its value? This is a way of saying reducing balance depreciation. So just write that in there and take note. So this one, sometimes they will say it's reducing balance depreciation, or sometimes they'll use the wording depreciates by 10% of its value each year. So that means it's new value every year. It's taking the 10% off that. Flat rate would be the same amount every time. So this is the 10% off the new value. Okay, so here they've given us the recurrence relation, and we can see that because they've given a VO and a VN plus 1 formula. And it says use the recurrence relation to find the value of the car after 1, 2, and 3 years. So remember, this is the same as yesterday with compound interest. We must show the working. So we've got V1 equals, now you just follow the rule, it's 0.9 times the one before. So the one before V1 would have been V0, which is 18,500. And remember, this is depreciating, so you want to see a smaller number here. And I'm just putting 0.00 because we're talking about dollars. So then V2 will be 0.9 times the one before. So I show that it's the one before, and then I write my answer, which is 985.00, and then V3 equals 0.9 times the one before, which equals 13486.50. So just to help you, remind you, I've put over here on the calculator. So remember, you type your original in, and you just press enter, and it pops up over on this side. Then what you want to do is when you press times in this next line, it says times answer, and then you go and you put 0.9, and then that shows, and it gives you and there's the first, the second, and the third. You just keep pressing enter after that. It can make it a lot easier to do it, because then with our question B, it says, when will the car first be worth less than 10,000? So I was up to 3, and then you can see I kept going, pressing enter. So there's 4, there's 5, and then I can see at 6. So I'm going to say after 6 years, or I'll write what V6 equals. So V6 equals 9831.66. So then I'll write therefore. That's just the symbol for therefore. A lot of mathematicians use it, so we don't have to write out the word. So after 6 years, it'll be less than 10,000. Okay, a ute is purchased for 53,800. So there's my VO, and the following recurrence relation can be used to model the ute's value as it depreciates. So here again, 8% of its value each year. So that we know is reducing balance. So you need to get into the habit of writing that and being aware that that means reducing balance depreciation. And you can see they told me what the R is there, the 8% each year. So I know that. So just to go over like what we were talking about with the rate. So remember this number here is our big R, yeah? And if you look in your reducing balance formula, big R was found by going 1 minus the rate over PPY over 100. So just to show you how they got that number, they did 1 minus 8. Now, because it was each year, PPY is 1 and over 100. And so when you do that on your calculator, that's how they get 0.92. All right, so you need to be aware of that. Okay, so it says, once again, we've got to use the recurrence relation to find the value of the ute after 1, 2, 3 years. So once again, making sure we write V1 equals, the R value, which is 0.92, times the one before, which was originally 53,800, and we get our answer. So this is just similar to the one before, but V2 equals 0.92 times the one before. So you must be writing all of this out to be getting your mark. And you're going to get it in your VCE exam, 100% this will come up, and it will not get the mark unless you're showing all this working out like this. So and I can tell you now for your exam, I will not give you the mark unless you do it properly. Okay, so it says, when will the value of the ute first be less than 30,000? So you can just keep popping it in your calculator like what we did before. And when you do that, if you keep going down recursively, you'll find that V8 was 27,611, and that was the first time it dropped under 30. So we write therefore after 8 years. Okay, so the following recurrence relation can be used to model the reducing balance. So here they've told you, so you know which one you're looking at on your formula sheet. And of a car purchased for 18,500, which they've written there, and the value of the car depreciates at a rate of 10% per year. So they told me little r there. Use a rule to find the value of the car after 12 years. So when they say use a rule, that means we're looking for the nth term formula. So if you look at reducing balance depreciation and you look for the nth term formula, this is what you've got this template here. Now you don't have to calculate R as such if you look at it, because you can see it up here in the question. So you can see R is 0.9. So the nth term formula could be written as the R value there, 0.9 to the power of n times VO. So we've got VO there. We've got 18,500. So there now I've created, this is the rule. And now they ask me to find V12. So if I'm finding V12, I'm going to type into my calculator 0.9 to the power of 12 times 18,500, and there's your answer there. And I'm doing it to 2 decimal places. Now, what I should keep going. Why should I keep going? What did that question actually say? To the nearest dollar. So what would this one be to the nearest dollar? 5,225. That's right. So nearest dollar, if you need to write a little note up there, this just means to round to the whole number. So it means no decimal places. Okay, whole number, no decimal places. So there's your answer there. So otherwise, if they don't say anything about, to the nearest dollar, you would put to 2 decimal places. It's automatically assumed that you know to put it to 2 decimal places. Okay, so the following recurrence relation can be used to model reducing balance. So you've got reducing balance, and you've got a car, and here it is. So you've got a car that was originally worth 18,500 and so on. So let's just quickly do these questions. So how much was the car initially worth? Yeah, 18,500. Now it's this question here, which came up yesterday as well in our compound. It says, what is the annual interest rate, annual interest percentage rate of depreciation? So really what they're asking is, that little r is the question. So we need to have this written in our notes. So you need to make sure you're writing this out nice and big, because this is a new formula. This is the one for reducing balance depreciation. So you can see it's a little bit different. When we're finding the percentage rate in depreciation, you can see we have to do a 1 minus that R. Where in compound interest, it was R minus 1. So there's a difference here. So make sure you take note. This one is different, and we're going to do that. All right, so if we follow this formula with this one, so with the example, so for B, we could go, all right, so if we're trying to find the percentage rate, we're going to do, it equals 1 minus R, which is 0.9. Can you see up there, we've got up in our formula up here, I can see that R is that number. So we're going to do 1 minus 0.9. Now times the PPY. This is just every year. So after n years, that's telling me PPY equals 1. and then, so times 1, and then always times 100, because that's going to give us the percentage. So if you type that out on your calculator, you'll see that it's 10%. So sometimes it is easy to look up there and say, oh, look, if you're timesing something by 0.9, it's dropping by 10%. But that's okay because it's yearly. But when we start to change it around, and it might be monthly or quarterly, it's harder to see. So we've got a formula to follow, okay? So when it says, I'm going to quickly just answer these questions as well, so we've got them. It says write down the rule for the car after n years. So they want the nth term rule. So if you look at that, we'd write Vn equals, now you do R, which in this case is 0.9 to the power of n, times VO, which is 18,000. So I've looked at my formula sheet for nth term for reducing balance, and I can see that's what the formula is. And then it says use the rule to find V5. So I could go V5 is actually 0.9 to the power of 5 times 18,500, which equals 10,924.07. And it says, and the last one, what does the answer in part D tell you? What did you actually calculate there? When I found V5, what did I calculate? Yep.
The value of the car after 5 years.
Yeah, good. The value of the car after 5 years. So that's all you have to do. What does it tell you? They're just checking that you actually can interpret this question. So you just have to say that. So the value of car after 5 years. Okay? They're just testing that you actually know. You're not just rote learning or, just copying off formulas.